we're happy to have with us today Eva Vivalt of the University of Toronto as of this year, previously of Australian National University. She's an economist who researches impact evaluation, especially in international development and in particular of cash transfer programs. And she also explores more general questions in Bayesian and meta-scientific reasoning. She's the founder of AidGrade, a nonprofit organization which aims to assess and improve the effectiveness of international development as well. So Dr. Vivalt, the floor is yours.
Thank you so much, and thanks for having me here today. So today I'll be talking about how much we can generalize from impact evaluations, and I have to preface this by saying this was a paper recently published in GIA just this past December, so I've got to apologize for presenting a published thing, but I thought given the focus of your group, it might be of particular interest, this paper to you guys, so yeah, hopefully this is of interest. And in particular, I'll be looking at how much we can generalize. This is from impact evaluations in development economics. And I'll be exploring, if there does seem to be quite a lot of variation in results, where's that variation coming from? So are the differences we see due to differences in implementation or context? Is it just sampling error? Or some kind of specification searching or publication bias? So we'll be exploring these things, and just to motivate this, we do impact evaluation precisely to inform policy. And so if results vary, we're going to be stuck. If we don't sort of know why they vary, we're not going to know what's going to happen when we try to do the same kind of intervention in a new context. So here's just a heat map of impact evaluations from 3IE. And essentially the darker colors there where they've done, they themselves, but they're sort of looking at a whole bunch of impact evaluations out there in the world in development. And so there have been, for example, a lot done in India, fair number in Kenya, China, Brazil, South Africa, Mexico. And here is another map of where there's aid flows. Now, obviously, aid flows go to a whole bunch of different things. Maybe they're not exactly the same kinds of interventions, but it's still to give an idea that, the kinds of places that we do the studies are not necessarily always the places where we're actually doing projects. So in particular, you can look here and just sort of see some obvious big differences, like say in West Africa compared to, not that many studies in West Africa, say, and things like that. And a lot of people have been concerned about external validity. Bold et al. Have this fantastic example of one particular intervention where they did an NGO did a smaller scale version of it. It seemed to have really great effects, so they scaled it up. And the second evaluation that they did, it had fairly different effects. Handalkat has this paper on site selection bias, which also clearly relates to external validity. And people have examined questions of external validity in particular contexts, like, for example, with conditional cash transfers, where there are a lot of studies of conditional cash transfers. There have also been these more general critiques that have been made. And so my paper is seeking to answer the question of, okay, well, but how much can we generalize in practice? Because external validity is not a binary thing. And ideally we'd like to be able to measure exactly how much, along the spectrum, not just 0 or 1, but how much can we generalize. So I said impact evaluations have been growing. This is a figure from Sabet and Brown, where they are showing, again, just some published papers and working papers in social science journals and health journals that have got impact evaluations. And presumably there's even more than this if you sort of broaden the scope of what they're looking at. I'll be drawing on some data set that was gathered by AidGrade, which is this nonprofit research institute that I set up, which essentially does meta-analyses of impact evaluations of development programs. So this is drawing upon this data set, and in particular from 635 studies across 20 types of interventions. Now, those meta-analyses were started in 2012 and 2013. Obviously, it takes a little bit of time to actually do a meta-analysis, but you can sort of see the list here that were started in each year. So these are things like conditional cash transfers, deworming drugs, all the way down to water treatment, performance pay, rural electrification. So there's a variety of interventions here, and I'll say a bit more later on about how these were selected. Okay, so my approach is going to be really straightforward. So first, I am going to start by discussing some common measures of heterogeneity and relate that to the meta-analysis literature and to generalizability. And once we sort of have a handle on how those things can relate to things we care about with respect to generalizability, then I will actually generate those statistics, run those meta-analyses within every intervention outcome combination. So remember, here was the list of interventions, and within those interventions, there are a bunch of outcomes. And so I'm going to be generating all these kinds of statistics within intervention outcome combinations, like, for example, the effects of conditional cash transfer programs on enrollment rates. And so I'll generate all those statistics and then try to look at some patterns more broadly, looking across the different intervention outcomes. And just to give you some idea of the takeaways, well, there is actually a lot of variation. This was not something I expected to see or wanted to see. It was this kind of disappointment. If you try to, build just a random effects model of what, using all of the set of studies in the pool, well, you would guess the correct sign of another such study only about 61% of the time. And if you try to calculate the root mean squared error of a prediction and compare that to the meta-analysis mean, just to put everything sort of in the same terms, the ratio of that root mean squared error to the mean, which you can think of as like your best guess of what's going to happen, is about 2.5. Okay, so that's not great. And not much of the variance was due to sampling variance. That's unfortunate, because if a lot of it were sampling variance, well, that's a problem we know how to solve. That just says, well, increase your sample size and you'll get, better estimates. Well, here that's not going to help you too much. There is some improvement if you use some kind of mixed model. So that, explains, maybe 10 to 20% of the variance. And you can also see, if you're looking across different intervention outcome combinations, well, larger programs tend to have smaller effect sizes. And also academic or NGO implemented projects happen to do better than government implemented ones. This is a bit unfortunate, because typically in development economics, you'll do these smaller scale pilots with an NGO often in the hopes that you find a nice positive effect. And then, if it's a good effect, then hopefully the government will scale it up. And so this kind of suggests that's not, you might encounter some issues in scaling it up. It's what it suggests. It's not a causal thing, even though the estimates themselves are from impact evaluations. By the time I'm doing these kinds of analyses, the data at that point is, there could be just some correlations there driving that.
Just a quick clarification question. When you're talking about the variance, you're talking about the variance of the estimates of effectiveness of the same kind of program, or across different programs?
Yeah, so this is all the things that I'm doing are based on calculations within intervention outcome. And then when I'm talking about these stats here, these are either like the median or the mean across intervention outcomes, but they were calculated within intervention outcomes. So like overall, I've got 57 intervention outcome combinations in my data. And so for the ones for which, I can calculate these stats, like, so for example, these points here are looking at the median intervention outcome. Okay, so the typical one in my set. Good question.
Thanks.
Now, some types of interventions do seem to do better. This is a little bit speculative, but because, at this point, you're sort of reducing it to the level of the intervention. And even though I have got these 635 studies in the data set, they're only over a certain number of intervention outcome combinations and only over a certain number of interventions, right? So, but nonetheless, it's sort of worth looking at because I think it is still nonetheless the largest data set out there on this. So smaller sample sizes when you sort of aggregate it up, but still potentially of interest. Okay, so I should tell you a little bit about meta-analysis models before going through the rest of it. It depends, of course, I'm not sure exactly. Some people may know this, it may be a review, but just to sort of bring everybody onto the same page here. So there's various kinds of models used in meta-analysis. One common one, if you think that you've got heterogeneity and treatment effects, is to have this random effects meta-analysis. So what does that mean? Well, you're essentially saying that there's not one true effect that holds everywhere, but no, there's like each study legitimately has its own effect that it's trying to estimate. And there's maybe some noise, so each study is going to sort of imperfectly estimate what it should have got. But nonetheless, it's got a different theta here, essentially. So the theta sub I, these are the true effects in study I, and your point estimates, those are your Y sub I's. So your point estimates are a function of the true effect plus some noise, okay? And your noise is just your sampling variance. So, maybe you've got a really small sample size, and so your estimate is really noisy. And the theta sub I's, I'm going to assume, are also normally distributed around some mean, mu, with some variance tau squared. So this tau squared you can think of as the interstudy variance, the true interstudy variance. So your overall variance in the point estimates you observe is a combination of the sampling variance and this true interstudy variance, okay? And what you can do, of course, is to build a more complicated model where you're trying to explain some of the heterogeneity you observe. So think of your meta regressions, for example. And here you have roughly the same setup, but you can see I've plonked in an explanatory variable here on the right-hand side for this theta sub I. It's a function of some explanatory variable x. So say, your impact of conditional transfers on enrollment rates, maybe you think, well, baseline enrollment rates really matter here. So I'm just going to, I think that those will predict and explain a lot of the variance. And so here we have what you end up doing essentially if you're doing that is reducing the amount of sort of unexplained residual interstudy variance. So you still have something that looks like a tau squared, but I'm just going to denote it tau squared with a subscript r in there to say, look, this residual tau squared is probably going to be smaller now that you've sort of explained some of the reasons why you've got different results in different places, okay? So you're accounting for some of those factors. Okay, so those are the kinds of general models used in meta-analysis, but how exactly are we going to deal with and measure generalizability in the context of this paper? And how should we think about it at all? And this was actually one of the hardest bits of writing this paper because everybody, I think, has got a different idea of what are some possible measures of heterogeneity or generalizability that we can look at. And so, I want to start out by going through actually a few different measures that are commonly used and then suggesting some useful ways of drawing upon them to come up with something we care about as a measure of generalizability. So here are some classical measures of heterogeneity that might be familiar to you. I would divide them into two buckets. So first, there are some measures that just capture variation. So think of your variance in your effect sizes, okay? So your variance of Y sub I. Or think of that true interstudy variance tau squared. Some fields, you also estimate a coefficient of variation. So think of this as the inverse of your signal to noise ratio or your standard deviation over your mean. If you've got meta-analysis estimates, then you can think of this as your tau over mu, okay, in those kinds of, in terms of those parameters. Now, variation itself is maybe not a problem if you can explain it. So sometimes people have also talked about this measure called the I-squared, which is the ratio of tau squared over the total variance. So, you can think, okay, well, this is sort of telling you how much remains that is, not the sampling variance. If it's a sampling variance, we can kind of deal with that. We increase our sample size, but there's this other component, which is, just truly, we can't explain in some way. We can't do something about it. And you can imagine creating some kinds of similar statistics after you do try to do as much as you possibly can to explain the variance that you observe. Okay, now, unfortunately, none of these measures is going to be perfect for what I'm trying to do, because remember, I have got all these different kinds of intervention outcome combinations. And so if I'm going to be wanting to make comparisons that generate these statistics within intervention outcome combinations, but then compare them across them, then I'm going to want ideally to have a measure to have several properties. It shouldn't depend on the precision or the units or the mean of those different intervention outcomes, essentially, the different estimates in those intervention outcomes. So think of, basically a grid. You've got a bunch of different interventions, and you've got a bunch of different outcomes, and all the time I'm going to be looking at the studies within each of those cells. And unfortunately, if some of them are in terms of percentage points, and some of them are in terms of standard deviations, and some of them are in terms of dollars, it's, you can calculate out things like tau squared, but you're not going to be able to, and it will be perfectly fine to make comparisons within the cell, but you won't be able to compare across intervention outcomes. So none of these measures is going to be perfect for my use. But there is something that we can do that was maybe going to be more comparable and also relevant for policy decisions. And so I'm drawing inspiration here from Gelman and Carlin and Gelman and Twerlings. They've got these papers talking about type S and type M errors. So a type S error is an error in the sign, and a type M error is an error in the magnitude. And they are thinking really of how likely a study is to replicate. And you can think of this in some way as capturing generalizability to the same context. And so it's, not too much of a stretch to think of, okay, well, can we leverage this kind of approach to think about the kinds of generalizability that we think about when we're thinking about external validity? So generalizability to different contexts, generalizability across studies. And in particular, you can think, well, look, if you are measuring, if you're estimating a Bayesian model and you get some estimates of your tau squared and your mu and, even your I squared, well, you can use these things to calculate the probability that, you've generated these things within a set. Okay, what's the probability that if you had a sort of another draw from the same kind of set, you would be able to predict the sign correctly? What is the magnitude of the error in the prediction that you would have? So we can calculate out these things, and some of them have the nice property, like the probability of having the right sign has a nice property that's easy to compare across things a little bit. It's more intuitive, and it's very policy relevant. Policymakers are certainly going to care about, well, what is the sign of this intervention? I want to do an intervention in my context. I only have results from other places. Is it going to work here? And how likely are the results to be off? Like, how badly are they going to be off? How large are they going to be? So these are just two very intuitive things that a policymaker might care about. I will say that they're not necessarily, the only policy relevant questions that we could be interested in, but this kind of approach you could use to answer other kinds of questions, if there's other bits of the data that other stats that you care about. But okay, so that's the general overview of what I'm going to do now in terms of how this is actually estimated. So recall that this was my basic model. And by the way, I did try to gauge the goodness of fit of this model. So you can be, you can rest assured that these normal distributions are appropriate. Essentially, I'm going to be using these Bayesian hierarchical models. And well, what's my prior for the effect of a particular study? Well, I remember I'm just, this is just from the model really, I just assuming that these things are normally distributed around some mean mu and with some variance tau squared. What's the likelihood? Well, I've got some data, so I can, use those data and generate a posterior. So this is just going to be, basically, just updating based on the data. And of course, I'm going to also need some priors for mu given tau and for tau. And so what I'm going to say is these are uniformly distributed, and again, update my estimates of these based on the data. And in particular, I'll sort of work backwards. I will generate, my probability of tau given the data, mu given tau in the data, and theta given mu tau in the data. And a mixed model is going to be very, very similar. For the random effects model, you had this distribution that you were estimating sort of in this kind of sequential broken down way here. And for a mixed model, it's very, very similar. We just have this, slightly different stats here, okay? But it's a similar kind of approach. And by the way, all the code and stuff is online if you're into that. So data. So I said there are these 20 interventions, which, I had that little table of earlier. And these are really trying to capture any impact evaluation. So whether it's experimental or quasi-experimental, like something using a regression discontinuity design or differences in differences, any kind of quasi-experimental thing, I will also include. I will do some robustness checks later that restrict attention to RCTs, but I'm being pretty broad in including anything that's, some kind of impact evaluation that tries to be causal. So have both published papers and working papers. Now, when AidGrade was collecting these data, they gathered these 85 base fields coded for each paper and some additional topic specific fields that they were, for example, for conditional cash transfers, say, maybe we want to know the amount of the transfer, what the conditions were, whether it was targeted at girls or boys or both, whether it was in urban or rural areas or both, the age ranges, grades, all that kind of stuff. But those kinds of details are not going to be applicable to, say, a program on microfinance, where maybe instead you want to know, well, what was the size of the loan that was given and things like that. So there were some intervention specific things that were coded, as well as these sort of broader variables. We tried to follow best practices and had double entry coding for everything. So 2 people checking it, and then if they disagreed, then a 3rd person arbitrating. If you're familiar with meta-analysis, it's a long and painful process. So I'll try to move quickly through this portion so as to not bore you. It's very, very painful, but essentially, you have to set up the search and screening criteria and extract the data. In terms of how we selected the interventions, so we followed slightly different procedures in year 1 and year 2, but roughly they follow the same path. For the details on the differences, I refer you to the paper, but roughly, there were different people involved in AidGrade, and we each developed a list of topics we thought would be potentially, basically potentially have enough papers on them, because even though impact evaluations have taken off in development economics, we're not in the great situation that health is, say, where you typically have way more papers, okay? You'll see I have got a table later on of how many papers there are. It's fairly small per topic. So we were trying to focus on ones where we thought there'd be a mass of papers. We consolidated those lists together, making sure that, things were about the same sort of narrowness of how they were defined, and that we were removing any overlaps. We did some pilot searches and shortlisted the papers based on how many papers came up in those pilot searches. In year 2, we had a public vote for one of them, having to do with a crowdfunding campaign. Okay, so we had that one selected women's empowerment projects, and then after that we even randomized the group that we were selecting partially to reduce it further. So we ended up with the final list of topics. Now, search and screening, this is, again, pretty complicated. We tested out various sources like Google Scholar and had a search string development. So we had some scripted searches that ran automatically, and we had some manual searches of certain repositories online. We then screened out the duplicates, and we did screening in the following way. Well, first we screened on the title. And again, this was double entry and then reconciled. We checked the references as well of papers and to see if there was anything we could pull back in, and screened out the duplicates again. We then screened the abstracts. After having screened the titles, we screened the abstracts, and we got the full text of the papers that passed, and those were our screened papers. For the data extraction, again, it was a big process to develop the coding manual and data extraction forms and extract the data using double enter coding. That gave us the raw data, and then we had to standardize the data. So here you may be familiar with, this is a standardized mean difference. So essentially think of the difference between two arms, so your treatment group and your control group, over the pooled standard deviation. So this is putting everything in terms of standard deviations. For some of the analyses, this is going to be important to try to put things in similar units. For some of them, as much as possible, at least in economics, people like to deal with raw units where possible. So, it depends on exactly which analysis I'll be presenting to you later, but, we also have some that are standardized. Unfortunately, some are lacking the information on standard deviations of the outcome variables. So it's a different set that we can do this for. Or you can do this if you're, willing to make assumptions about, say you've got a whole bunch of studies within one particular intervention outcome combination, and they all report the standard deviation, but this one study doesn't. Are you willing to extrapolate to that one? But anyways, and the other thing that we did to get everything ready to be analyzed was to sort of flip the signs on some of them, so that positive thing is always a good thing. So I think some of the things would be, for example, measuring the decrease of the incidence of the disease. Well, that seems like a decrease, but actually it's a good thing. It's a positive. So for just to help with interpretation. Okay, now when looking at the ability to generalize within a set, how you define the set is critical. So 8th grade had tagged on these 3 different types of outcome definitions, from the more strict and specific to the broad ones. I'll give you an example, like height in centimeters. That would be a strict outcome. It's really clear what it's measuring, and there's like no leeway, like it's measuring the same thing. For generalizability, we're going to be basically focusing on the strict outcomes and looking at those that have got the studies that have outcomes in common, which is actually a very small subset of the ones out there, because unfortunately what the papers all try to do is they sort of run away from each other in what they're studying. Maybe this is publication incentives, I don't know, and nobody wants to be, everybody wants to be the first paper on something, so they kind of run away in terms of what they study, unfortunately. I should say about the strict outcomes, we did have a couple of looser ones for malaria and anemia, I believe, because we want to look at bed nets and micronutrients. And if you think of, what's the main thing that it's driving at? Well, it would be really lame to look at bed nets without looking at malaria. So, but you can obviously try to diagnose whether somebody's got malaria differently. All right, different places kind of have different norms. So anyways, both those 2 exceptions, it was otherwise strict. Now, there is a separate paper that I wrote using the full data, looking at specification searching and significance inflation. So if you're interested in that, I would refer you to there. I'm not going to have time to talk about today, but essentially I didn't find much evidence of it in the sample, and particularly not for RCTs, which is great. It's kind of actually backs up some work by Brodeur et al. That they also found little evidence of bias amongst RCTs in economics. So what I'm going to take away from that is, well, great, I can use a subset of RCTs in my data as a robustness check to, mitigate the concern that any differences that one observes in treatment effects across different places is due to somehow, some additional variance from specification searching. So it would just be a robustness check as far as I'm concerned here.
If there was, what would evidence of that look like in your data set?
Yeah, so for example, so what I did in the other paper and Brodeur et al. Have done is look, for example, just on either side of the threshold for significance. So look at, papers that are just narrowly, or results that are just narrowly statistically significant at the 5% level versus not, and sort of see if there's a sudden jump just at the 1.96 level. That would be some evidence that if you're looking within narrow enough bands, if you see a discontinuous jump there, that would be alarming. And that is a thing that, so Brodeur et al., they looked at a variety of different methods and found quite substantial jumps for some other methods. So it is a thing that you can observe. And in fact, it was also, I think, building on some work that other people have done in other disciplines like political science and sociology, where they also kind of found these kinds of jumps. So I'm mostly looking at these kinds of like caliper test results, but obviously there's going to be different kinds of publication bias, and I don't want to overclaim here. There's maybe some kind of bias that is unobservable because it's affecting everybody in some way that is not dependent exactly on significance. Maybe there's something more complicated going on. But I still think nonetheless it is notable that if you don't, given that there are lots of cases where you do see this discontinuous jump, not seeing that discontinuous jump right at the threshold for significance is pretty good evidence, I think, for people at least not specification searching in the way that gets some narrowly significant results.
Thanks.
Great question. Okay, so here is the distribution of those strict outcomes in question here. So you can see here the number of outcomes and the mean papers per outcome and the max papers per outcome. So there's not, and this is already, I think this is, this is already sort of restricting attention. Like you can see, like all of them have like at least two, but it's pretty bad. I mean, there's a number of like the mean papers per outcome is about 6. Okay, that's something, but you're not going to have like 20 papers for all these 20 topics. That would be amazing. That'd be great. Or even if you have 20 papers per topic, that would be like per intervention, not per intervention outcome combination. And since we want to do all the analyses within the intervention outcome, that little cell is the one that matters. Okay, so let's get to some results here. So here first, I'm just plotting out some of the variation that can be observed. This is the standardized mean differences so that everything can go on the same chart. And so here what you see is all those intervention outcome combinations down that left-hand column. So say the effects of conditional cash transfer programs on attendance rates or on enrollment rates. And so what you see here is the maximum and minimum values, the interquartile range, as well as any outliers, okay? So most of these, and this is restricting attention to those that have, at least enough in their cell that you can calculate these kinds of things for, okay? You're not going to have an interquartile range with 2 papers in it or whatever. So most of these are roughly clustered around 0.1 standard deviations. Now, this is including things like a paper was done on conditional cash transfers and sort of, it was mostly interested, say, in enrollment rates, but peripherally, it also picked up something on test scores or something like that. So, you can think of this as potentially a lower value than you might think, like, oh, the average intervention or the average effect is about 0.1 standard deviations. Maybe that sounds pretty low. Some of this is getting at these sort of peripheral outcomes, or the ones that were not the main intent of the authors of the paper. Nonetheless, the other thing that sort of jumps out is that there is, I think, a fair amount of variation here. I guess it depends on your priors, but a lot of them, if you look at different types of interventions that cover the same outcome, you can't distinguish between those different interventions. Like they overlap, okay? It's not like one of them is a clear winner. Okay, so let me just sort of summarize some of these measures of generalizability by heterogeneity. So remember our heterogeneity measures, well, one of them is frequently used as tau squared. So here's our estimated tau squared using the full set of data in the cell. So that's subscript n with the hat over the tau squared to show it's estimated based on all the data in each cell, each of the intervention outcome combinations. And also here you've got the mean. And so let's just look at the first little block here. So this is the probability that you'll be able to correctly predict the sign of a similar intervention, a similar study. And so if you've got high mean and a low variance, you can predict that sign pretty well, like 98% of the time. If you've got a low mean and high variance, though, it's basically a coin toss whether you'll predict the sign correctly. And you can calculate this as well for the root mean squared error, although it's a little bit harder to interpret just because the root mean squared error is going to depend on the units. So now this is where you get into, well, different intervention outcomes have got different units. And so this particular thing is not in terms of standard deviations, but in terms of the raw units. And so it's going to be a little bit harder to interpret. But nonetheless, you can sort of see the same kinds of, variation where, the higher your estimated tau squared, the higher your root mean squared error is going to be. Of course, this is sort of collapsed down to intervention outcome combinations, and there are not that many of them. So once you sort of collapse it down to, those where you've got a number of them such that you feel confident making these kinds of estimates, okay? And here, this is sort of a key table summarizing some of this, showing you the different quantiles, as it were. So how you should read this. So think of all those intervention outcome combinations, and this is like your 50th percentile of intervention outcome combination. So remember I was saying your typical intervention outcome, you're going to be able to guess the sign correctly about 61% of the time. So this is coming from this table here. And what you can see are the different, you can again see the root mean squared error, you can see tau squared, you can see I squared, you can see this thing that's kind of like the coefficient of variation, but using the estimated parameters. And you can see the mean and error number. Now, each of these columns is independent of the other columns. So this is the 50th percentile, this is the 50th percentile for the sign. It's not necessarily going to be the 50th percentile for the mean. This is like the 50th percentile for the mean, and it might be a different intervention outcome. So when I say that the ratio of the root mean squared error to the mean, and you divide those up and you say that's a different number, that's where that different number is coming from. These are sort of independent of each other. But they give you a sense of, well, how are these things distributed? And you can see the lowest quartile of the results, it's maybe slightly better than a coin toss. The highest quartile of the results, you can predict it reasonably well. For RCTs, maybe some of the middle bit is, the median is a bit better. Not, really distinguishable, but maybe. Yeah, so here you can sort of see it broken down by all studies, RCTs, and some measure of higher quality studies based on a set of attributes that they had. The RCTs, I should say, what I would have liked to have done is look at how well RCTs predict non-RCTs and vice versa, because that's a big issue in economics, at least. But this is actually all within the set. So this is looking at any study that's an RCT, and then looking within the intervention outcome combinations amongst RCTs. So this is RCTs to RCTs, not RCTs to non-RCTs. the reason is that, unfortunately, so I did try to look at RCTs to non-RCTs. There's just not that much overlap, because things, some kinds of interventions happen to be particularly amenable, it seems, to evaluation by RCT, and other ones less so. So they kind of clustered together in a way that divvying it up made little sense. Okay, so these are some of those summary stats that I drew out before. Let's turn to modeling some of that variation. Now, oftentimes there's not going to be enough data to do a meta regression, unfortunately, just because, again, think of doing this within those intervention outcome combination sets, like how many observations are you going to have in a cell? Probably not that many. Nonetheless, what I did was I tried to pull out the single best fitting explanatory variable for each of the intervention outcomes that had at least 10 papers on them, and were economics ones. So here you see the single best fitting explanatory variable for each one, and what the R squared of that was if you just sort of plopped it into a meta regression. And you can see it does sort of reduce the tau squared by some amount here. So you have the tau squared calculated without putting that explanatory variable in, the residual tau squared with the explanatory variable, and how much of a change that is. Now, this, I should say, some of this is based off of a pretty small sample. So let's look at the last row here. I'm pretty confident that this is not an R squared of 0.92. I think that's overfitting because it's a very small sample. And even though these intervention outcomes are those that had, I think, 10 papers within the set, they might not have all of the explanatory variables. So, some of them just don't report all the things that we want them to report. So there's even more missing data in places. So this is where I'm saying, on average, you're able to sort of reduce the variance by about 20%, but the median is more like 10%. So it helps, not super much given the small sample sizes. What other general things can we say? Well, I mentioned this is just regression of effect sizes on study characteristics, just OOS. So here, your larger studies have smaller effect sizes. Your government implemented projects, unfortunately, do particularly poorly. The group left out here is those that were implemented by private sector firms. So not that much going on with respect to RCTs, like maybe a higher point estimate, but it's not significant. And not really much going on with regional dummies here. This one seems significant, but I think it's based on a small number of observations, so I wouldn't put too much weight in it. I said there are some interventions that maybe do better than other ones. Here you can see I partitioned out some of the interventions into the health ones and the non-health ones, as well as some of them were conditional. So think of conditional cash transfer programs, performance pay. Those are giving people money conditional on taking an action. So you might think, if you're thinking in terms of causal chains, et cetera, that they're kind of more direct. And with some caveats, namely that tau squared is going to depend on units, and with all those caveats, it does seem like there's maybe something going on here. Not so much if you're looking at the I squared. So again, I don't want to lean too much on this. And also, actually, I think this. I think this is based on the standardized values, because so there were 47 intervention outcome combinations which could be standardized. So this is the observations are the number of intervention outcome combinations, and these are sort of relevant, but yeah, you might still say, well, there are correlations. Now there is some hope. You can go more in depth onto any of these things. So in particular for conditional cash transfers on enrollment rates, there's loads of studies on conditional cash transfers, and enrollment rates is one of the basic things that a lot of studies want to cover. So here is just OLS regressions on some of that. In fact, I have got more columns in the table here in the actual paper. I just had to cut them off for the sake of size here. But basically you can see, if you are able to look at some more detailed things, so baseline enrollment rates and just a binary, you're enrolled at baseline or not type thing, you get a little bit of better fit, and some of them go up to like an R squared of 0.5, depending on, we had other measures here too, like girls, boys, etc. So I recognize, time constraints, so let's just try to wrap up. So overall, I would say, look, the impact evaluations in development economics have got significant predictive power. Nonetheless, there remains quite a large amount of dispersion of the results. I do think that generalizability is improved by considering these other factors. We're just not generally going to be in that luxurious state of looking at the impact of CCTs on enrollment rates. Usually we'll have far fewer studies in a particular set, right? There's dozens and dozens of CCTs, not so for some other kinds of programs. And we do see that those larger programs and the government implemented ones, unfortunately, do a little bit worse than the smaller NGO or academic implemented projects. And finally, some suggested evidence that those interventions that have more direct causal chains maybe fare a little bit better. I will just leave it there and see if there's questions.
Thank you very much for that talk. That was great.
Yeah, that was outstanding.
Start us off with the question.
First, I just want to give a round of applause to Eva. That was amazing work. It was a fantastic talk. Thank you very much. So
Thank you.
I'll do virtual clap here. Yep. Thank you so much. But I have some questions, but I'll wait. I'll let anyone else in the audience go first. All right, I'm going to cut in then.
You could go ahead.
Okay, great. Yeah, again, that was a fantastic and amazing amount of work to went into this, and you did. Super useful. I know I work on a lot of randomized trial design and analysis problems, and I have a brother who's an economist who also looks at a developmental economist who also looks at some of these studies. And it's much needed what you did. So very impressive. Thanks for doing that. I was wondering that you may have already covered this. I apologize if you did. That were there certain areas where the evidence seemed to be stronger, certain types of interventions among the different ones that you discussed? Did any stand out as these seem to have the strongest evidence of effectiveness?
Yeah, so I should say one thing that is a complicating factor is that I didn't look explicitly at cost effectiveness, which is maybe the thing that would speak the most directly to what you're getting at there. I know that, other people have generally found that, deworming drugs, since they're so cheap, are particularly cost effective, or bed nets. But actually fairly few papers reported information on costs, and not in a way that could be sort of standardly extracted. So unfortunately, I have no cost effectiveness things, which makes it a little bit hard to make these comparisons. I will say that without looking at cost effectiveness, without having the cost side of them, in terms of the impacts, they basically all overlap. So I think the cost side is actually going to be the key driver there.
Interesting. Okay, that's useful to know. And do you, based on what you found, if you were to allocate money, if you're going to make a donation, say, or someone's considering making donations to some of these organizations that do these, implement these kinds of interventions, would you? It might not be possible to make a recommendation, but would you have any recommendations? Would you say something like, well, hedge your bets and just divide up among a lot of possibilities? Or do you have a few that stick out that you think might have the best chance of having impact? Of course, cost, like you said, is going to have a huge impact there, but I was wondering if you had any thoughts on that.
Yeah, so I mean, to be honest, I think that because cost would have like a huge impact on that, and also I would think that the actual so, you know, there are these like charity evaluators like GiveWell say that look at particular charities that are doing work in particular places, which I would say, yes, you know, this is essentially saying don't look at the intervention outcome, like don't look at the intervention level, go to the specifics of like, where are you doing this? I mean, I think that you know, the best answers I could give you on that would not be based on this paper and would be based on those kinds of things that other people have done.
I see. Well, I might follow up with you. Sorry for pulling it away from what you presented, but I'm very curious about any. And do you? Can I still? Well, I'll stop there. I don't want to hog up all the questions. So, but thank you very much. Yeah. No, I want to turn it over to other people. I don't want to be so. Great. Thank you so much.
So I know you mentioned the difference between standardized and raw units, but what are the measurements typically in these studies? Because it seems like depending on what measurement you choose, especially for something like cash transfers, like that might have by definition a large effect on wealth, but then when you look at something downstream like mortality, it might be sort of attenuated. So like, how do people choose what to measure, and what are the measurements in these studies typically?
Yeah, no, that's a great question. So, you know, I think people don't typically measure sort of the downstream effects. Unfortunately, it would be great to have. People most often evaluate the things that are sort of like the immediate impacts, and also not so much like, you know, longer term impacts. Some of it you can imagine potentially being attenuated. In terms of the raw units, I mean, I think you know, most papers are going to report things in the raw units. The standardization is mostly useful when you're trying to make comparisons across different things, but then you can say, well, look, they've got different standard deviations too. So is this really making them comparable by putting them in terms of this thing that is also different? So it's not a totally straightforward thing. I mean, I think the one thing that's a big takeaway is just how much papers are not measuring or reporting. There was a surprising, a lot of papers didn't even report actually who implemented it. So given that we observe, you know, differences between NGO implemented and government implemented projects, that's a big red flag. And I think there's, you know, a lot of room for collecting more sort of long run impacts as well. People are starting to do that now slowly, but only of like particularly large consequential programs.
Any other questions? Yeah, if there aren't other questions, I think I would also be interested in Michael's line of questioning if you want to go back to that with our last few minutes.
Yeah. So you know what? No, go ahead.
Well, I was going to ask feel free to talk about what you're going to say, but I was going to ask about what you think of how much credibility do you put into evaluations by groups like GiveWell, who claim to evaluate the effectiveness and the impact of interventions of the type that you're talking about?
Yeah. So I will say that I have been historically a bit more skeptical. I think I remember seeing the earliest version of their website years and years and years ago, you know, and it was pretty bad. I think they've really worked a lot on it, and they do things like try to break down estimates by you know, figuring out what they think the underlying baseline rates of things are. So like, you know, in some of my work, I see that the baseline rates are one of the biggest predictor of what kind of impact a program will have. And they do try to account for like, what's the baseline prevalence of worms or whatever, you know, what's the, you know, I think, you know, they're reasonable. I'll also say there's some people who are also now focused more on, okay, well, if the effects are sort of temporary, you have some temporary improvements and then they sort of go back to the steady state. Is this worthwhile in some sense, or is it better to, try to improve things a little bit later on? So there's also like a separate question of like giving now versus giving later. If you give later, you can save your money now, invest it and get a return on that investment. And then if later you're in the same situation in some sense, and so there's a question of like, what's the impact of affecting people's health and education, and how will that grow and change their trajectories versus there's like that other element which is not even captured, I think, in some of the more standard ways of making comparisons.
That's a really good point. Great. Well, thank you so much. This is excellent work. I really appreciate it, and very clearly explained as well.
Thank you so much.
Yeah, thank you very much, Eva. And I guess with that, we'll wrap it up, and I'll see you all next time. So long.
Take care.
Thanks, Brian. Thanks, everyone.